All right, seniors, welcome. Another beautiful day of home learning here. Today we're going to talk about bearings. So this is something we discussed in the beginning of the unit when we were talking about right triangle trigonometry. But I want to talk more in depth about it, and I try to be a little bit more explicit since I'm trying to teach you from afar, and I'm not really there to answer your questions. So you may remember that I introduced you to the concept of bearings in section 5 of this unit. Bearings are just a numerical way to represent a direction. All right? In the compass below, you'll see that each direction is associated with the bearing. So north is represented with 0 degrees, and then you move clockwise around the circle with the bearings increasing in 90-degree increments with each cardinal direction. So essentially, north is 0 degrees, and east is 90, south is 180, west is 270, and if you come all the way back around to north, you would get to 360 degrees, but on a compass, you would just start back over at 0 for north. Okay, so the important things you understand is that always start at north with being 0, and then you work your way clockwise around the compass. All right, so when I give you problems, I'll always include a little compass rose that looks like this. This is just a visual way for you to draw what's happening in this situation. So what I mean by that is maybe I say you start at a trailhead and you hike at a bearing of 80 degrees. All right, well, here's what that would look like. The center of this little compass rose would be your trailhead, and a bearing of 80 degrees would be going around, starting from 0, going around clockwise, but not quite to 90. So you would end up right about here. And what you would know is this angle, starting from 0 degrees or north, is 80 degrees. And that would leave 10 degrees for this little angle between the bearing you're on and east. So we're just going to apply that in a couple problems here, makes you understand the basic concepts. And one other thing I suppose I want to point out real quick is that your iPhone has this capability, for those of you that have an iPhone, and even on Androids I bet they also have a compass as well. But if you go to the compass app on your iPhone, you'll see that when you use your compass, it'll associate a bearing with whatever direction you're pointing. And I have a little screenshot of a phone here I can show you. Let's see, right here, check it out. So this screenshot shows, let me see if I can grab this and put it into the notes here. This screenshot shows someone going on a bearing of 42 degrees. And so, remember, here was north. All right, so north is this direction. And when you point your phone the direction you're going, it gives you a bearing. So I know by looking at this phone screen, this little screenshot of the phone, that on a bearing of 42 degrees, I am going 42 degrees clockwise from north. So if you take out your iPhone, you go to the compass app, you could track, like, on what bearing do you walk from your bed to the door of your bedroom? Or what bearing do you walk from your kitchen to your living room? And you can use your phone and determine that. So it's something that's pretty commonly used, and especially for our purposes, for applications of trigonometry. All right, so let's do some examples. All right, so all I ask you to do here is to just draw a ray, just like an arrow, that represents the given bearing, and to determine the measures of the angles formed by that ray and the given rays. So what I mean are like these rays for north, east, south, and west that already exist. So take a look. And it's just like that previous example. All right. So first one says that you're going to go on a bearing of 100 degrees. So what you do is you'd start off. You'd be like, all right, well, this is 0. And my bearing is getting bigger and bigger and bigger. I'm probably around like 70, 80, 90 degrees. So bearing of 100 degrees would be right about here. All right. So then the next part of that question is, well, what are the angles formed with this ray and the given rays? So if this is a 100-degree bearing, started at north and went 100 degrees clockwise, that leaves 10 degrees for this little angle because I went 10 degrees past 90 to get to 100. And also, I'm 80 degrees shy of 180. So this would be 80 degrees. All right? So I went 100 degrees, drew my bearing. Well, 100 degrees is, 10 degrees past 90, and it's 80 degrees prior to 180. And the other thing to remember is always these two angles are complementary, so they're going to add to 90 degrees because the north-south line and the east-west line are perpendicular to one another. All right, so let's do another one. 240 degrees. All right, so I'm going to start. Here's 0, and I'm going to rotate around. So I'm getting bigger. I'm at 90. I'm at 180. I'm not at 240 yet. So if I'm at 180 and I need to get to 240, that's 60 degrees past 180. So I don't know why it stopped there. Let's try that again. So this is 90, 180. To get to 240, I need to go 60 degrees more, or 30 degrees before I get to 270. So this will be a bearing that represents 240 degrees. And 240 is 60 degrees past 180. 240 minus 180 is 60 degrees. And it's also 30 degrees shy of 270. So if I said, hey, I want you to walk on a bearing of 240 degrees, you're going southwest. All right, and then the next one is 330 degrees. All right, so first thing you could do is you could be like, all right, well, I'm going to work my way around. Here's 90, here's 180, here's 270. Well, 330 is 60 degrees past 270. So I could go 60 degrees past 270 and go right here. But another quicker way to think about it is that all the way around the circle is 360 degrees. So 330 is just 30 degrees shy of a full rotation around the circle. So if you wanted to do it a little bit quicker, you could just go this direction, and that's 30 degrees before you've reached 360. And also, as I mentioned before, 330 degrees is 60 degrees past 270. So there we have it. All right, so when in these problems, I'll say you walk on this specific bearing, you just start at 0 and keep rotating around clockwise until you get to that number. All right, so next application. So here I just have your north, south, east, and west lines drawn, and I have some little directions of travel that are indicated with rays. So I got like from O to B, O to C, O to D, and O to E. All right, so the first thing this problem asks you is to solve for these missing angle measures. So W, X, Y, and Z. So to do that, the key thing here is just to remember that the north ray and the east ray are perpendicular, all right, and so forth and so on. So between this north-south line and this east-west line, they're perpendicular, so the angles inside are always complementary. So if this angle is 30 degrees, for W, that will leave 60 degrees, because 30 and 60 gives me 90. For X, all right, well, I know that these two angles, the 40 and the X, must be complementary or add to 90 degrees. So if this is 40, that leaves 50 degrees for X. For Y, same deal. I know the 25 and the Y here, they form this right angle. They're complementary. And so 90 minus 25 gives me 65 degrees for Y. And then for Z, Z is right here. It's this angle right here. And I know that to find that angle, the 40 and the Z need to add up to 90 degrees. So that leaves 50 degrees for Z. There you go. This is the first type of thing you'd have to be able to figure out in given one of these situations is once you draw that bearing, well, what are all the angles around it? All right, next is actually to identify a bearing. Now remember, bearing starts at 0 degrees, which is north, and works itself around clockwise. So I want to know what's the bearing from 0 to B. So I'm starting at 0 degrees. Sorry, bearing from O to B. Starting at 0 degrees. And now let me rotate around and see how many degrees I need to rotate before I go from O to B. Boom. Right there is the bearing from O to B, and I have rotated around 60 degrees from 0. So that is on a bearing of 60 degrees. Oops. Sorry. All right, let's do another one here. Let's do... I keep deleting that. Here we go. All right, the next one says a bearing from O to C. All right, so here's O. Here's where I'd start. But I'm not going north at 0 degrees. I'm going to C. So rotating around. That's 90 degrees. And then to C, that's 50 degrees more. All right, so from O to C, that bearing is 90, 50 degrees past 90 is 140 degrees. Or you could also think about it that all the way around to here would be 180 degrees, but it's 40 degrees before that, which is 140. All right, let's do the next one from O to D. Maybe I'll change colors to make it easier for you to see. All right, so here we go. From O to D. So I'm starting at 0 degrees, I'm rotating around, that's 90, that's 180, and to get to D, I need to go 65 degrees past 180. Boom. Well, 65 degrees past 180 degrees gives me, so from here all the way around there, 65 past 180 is what? 245 degrees. Or you'll notice that's 25 degrees before you got to 270. So you could have done 270 minus 25, which also would have given you 245. All right, and then finally the last one here is what's the bearing from O to E? So again, you could start here and you could say, how far am I rotating around? That's 90, that's 180, that's 270, that's 40 degrees more past 270. You could totally do that, and 40 degrees past 270 is 310. But you could also think about it from the other direction. Say, all right, well, all the way around is 360, but I went 50 degrees before that, and 360 minus 50 is 310 degrees. So the key with bearings, start at 0 and rotate yourself all the way around, and one full rotation is 360. All right? All right. And then, I tell you what, why don't I stop here? This will be part 1 of today's lesson, and then I'll pick up with these examples here.